everyone. Welcome you all once again. I'm Meghamala, working as Assistant Professor from Electronics and Communication Department, Institute of Aeronautical Engineering. So coming to the topic, and today's topic is all about, we'll be learning more about looping statements. Okay. So today's topic is about the looping statements. So we'll discuss what are the looping statements, different types of looping statements that we come across in the Verilog. So here, the looping statements, there are 4 types of looping statements we'll find in this Verilog. As we all know that when we compare the Verilog language with the with respect to the C language, we see there is a similarity between the C language and the HTL language. But when you compare both of the languages, Verilog language is a case-sensitive language. Okay, and the rest of the things you will find the same when we compare with the HTL and as well as the C language. So here, coming to the looping statements, there are some constraints we'll find in this looping statements, and those constraints are similar like like in the C program as well. So in the looping statements, there are 4 types of looping statements we have, and they provide the means of controlling the execution of the statement 0, 1 or more times. So here the execution of the statements, okay, the execution of statement can be done with respect to 0, 1 or more than 1 times. We'll see the execution of statements, okay. Why? Because just to control the process, in order to control the process, the execution of the statements can be done 0 times. That means no time, and also 1 time, and as well as more than 1 time. And forever continually executes a statement. So here we see 4 types of looping statements we had. So the first one is forever, repeat, while and for. So these are the 4 statements that we come across in this looping statement. So when you come across this forever looping statement, the forever looping statement states that it continuously executes a statement. So forever looping statements, it says that the execution of the program takes place continuously without any break. And then repeat statement, repeat looping statement. This repeat looping statement, it executes a statement a fixed number of times. So repeat looping statement, it executes the consent statements with a fixed number of times, whereas forever, it executes continuously. Forever executes the statements continuously. Repeat, it executes fixed number of times. And coming to the while statement, it executes a statement until an expression becomes false. So while executing, we may see sometimes the execution goes at true, sometimes the statements goes with the true, okay, true conditions, but not all the times true, but somewhere will end up the statement with the false. So whenever the statement is ending up with the false, then the execution statement until the expression becomes false, the statements will execute with a while. Okay, so the while executes a statement until an expression becomes false. And if the expression starts out false, the statement is not executed at all. So unless and until the statement is not executed false, then the while loop will not continue. Okay, the while loop will not execute further. Until and unless it must execute, it must becomes false. When the statement or else when the condition becomes false, then only the while loop, it just executes the statements. Okay. And coming to the for loop statement, here the for loop, it controls the execution of its associated statements by 3-step process. Okay. So here for is the condition, as we all know. So for statement, it controls the execution of the statement by the 3-step process. How means here. See, for looping statements, it has to undergo the 3-step process. So here the first step is about the for loop statement it executes an assignment. normally used to initialize a variable that controls the number of loops executed. Okay, so this statement is just giving us a bit of knowledge about the number of loops executed. It controls the execution of an assignment normally used to initialize a variable. For example, we'll initialize, right, for I is equals to 0, I less than 1, then I plus plus. This is how we initialize. Okay, so just to initialize a variable, I'm initializing my variable 5 for I is equals to 0. Okay, this is how I'm initializing. So this statement, it executes the assignment normally used to initialize a variable. I'm initializing that controls the number of loops executed. Okay, so this loop, it controls the number of loops which are executed in that particular statement, in that particular block. How many times of the number of loops executed by initializing a what do we call variable. And the next step is it executes an expression. Okay, it as well executes the expression. If the result is 0, the for loop exits. Okay, if the result is 0, the for loop exits, and if not 0, the for loop executes its associated statements. That means what? For suppose here we have statement 1 to 4. Okay, so here my statement got executed one very well, and in the second statement, what am I doing? My result, I found my result as 0. Okay, when I got the result as 0, then here for loop, it ends here itself. Okay, instead of not going to statement 3 and statement 4, here itself my output got 0. I got my output as 0. So here in itself, until the second statement 2, my for loop will ends up. But in case what happens when my output is not getting 0, if I'm getting some non-zero values, 1 or 2 or 4, so on. So if I'm getting non-zero values, what happens? My for loop, it executes the rest of the statements. Okay, it will not end the statement, but whereas it goes on executing the rest of the statements. Statement 3, statement 4, statement 5, and so on. But the important thing to remember is whenever the result is output becomes 0, then there itself the for loop will exit. Okay. Rather than that, if I'm getting my output as non-zero value, then there's no problem. It executes the next statement, associated statements. Okay. And the third one is it executes an assignment normally used to modify the value of the loop control variable. So in order to modify some value, that means what? For I is equals to 0, I less than 1, I plus plus. This is what my initial variable condition. Then in sometimes what happens? I wanted to change the value of some variable. Okay, I wanted to change the value. That means what? Instead of 0, I want to place for I is equals to 10. Okay, so what am I doing here? I'm just changing out I'm modifying. Okay, I'm modifying the value of the pertaining variable. So in order to modify, we can also go for this loop, for the for loop. Okay, so just in order to modify the numbers or the values of a particular variable, we can go for a for loop statement. Okay, so this is all about the for loop. So what is a for loop states? It can execute normally for the initialization and that to control the number of loops executed. And the second one is for when I'm getting the output value as 0, that is if my result is 0, then itself the for loop will exit. Okay, if I'm getting, for suppose, a non-zero value, if my output I'm getting as a non-zero value, then also it will execute the associated statements followed with it. Okay, and the third step is it executes an assignment normally by modifying, normally used to modify the value of in order to control the loop variables. So we can modify, there's a chance of modifying the values as well. Okay, so these are the 3 things that we can see, or else that we can use easily when we go for the when you want to choose the for loop. And so here goes the syntax as per the rules. So the syntax goes like this: first statement and forever. So here in this particular syntax, we'll see forever statement. Okay, we have forever statement followed with the begin keyword and then statements executed and then ending up this particular statement for. This is all about the forever. Okay, and this is all about the repeat, and this is all about the while, and my next slide is all about the for. Okay, so as we said that these looping statements are categorized into 4 types, right? 4 types of looping statements we can use. First one is forever, repeat, while, and for. So for each and everything, the syntax goes like this: forever statement begin, statement plus, and this is for repeat. For repeat, state expression with the followed with a statement, and then repeat the expression and then begin. This is for while expression statement, while expression begin, and here goes with the for assignment. 2 kinds of assignment with the expression and then assignment. So what is this assignment, expression assignment? What is this assignment mean? In the previous class we have discussed, right? So what is an assignment? Dumping some values onto a variable is nothing but an assignment, isn't it? Let's recollect. What is an assignment? Assignment is dumping some value into a variable. So let's say my variables are A, B, C. So for this A, B, C, my variables, for suppose these are my input variables. So what am I doing? As a designer, I have to give some values to the input, isn't it? Sometimes there is a chance, there is a time where the output can be also given some values. Okay. So as a designer, I just wanted to give some values to a variable. So I am just giving my input variables A, B, C as values 10, 20 and 40, for example, say. So this is nothing but the assignment. So here in the for loop condition, for loop case, we'll see for assignment. So that means for I is equals to 0. I is a variable and 0 is a value. For suppose, as I said you, in the for loop, we can modify the values as well, isn't it? In the previous slides, we have discussed in the for loop statements, we can modify the values of a particular variable as well. So here, in the case 1 for loop, I is equals to 0. This is what I have given the value for the variable I. And then I can also modify as I is equals to 10. Okay, so I is equals to 10. And the expression that is I less than is equals to 1 or else 10. And then assignment again, I plus plus. Okay, or else 10 plus plus, like that. And then follows with the statement, and as well the statement plus n. So this is how we will be writing the syntax for the particular forever, repeat, while and for. This is the procedure that we need to follow when you're writing some looping statements. And then coming for the while loop, we'll discuss in detail what is this while loop, what is this forever loop, what is this for loop, and as well what is this while loop. Okay, so here coming to the while loop, the syntax for a while loop is while condition procedural assignments. So coming to the procedural assignment, in the previous module 1 I guess, we had discussed different types of the statement: procedural statement, assignment statement, procedural continuous assignment statement. And when it comes to the continuous statement, we had discussed about continuous statement, procedural statement, and continuous procedural statement, isn't it? So here in these 3 kinds of statement, we had discussed about the variables. So we discussed that variables could be of either in vector or scalar form. Okay, already we discussed what are the vector form and what are the scalar form. And also coming to the procedural example, here too we have the representation of the variables. It could be in the vector as well as the scalar form. And also here we'll represent with the net, wire, okay, some keywords, okay, some specialized keywords will be used in this procedural assignments. And coming to the continuous and procedural assignment, the combination of both, the concatenation of continuous plus procedural assignment can be seen here in the third one, continuous plus procedural. So here, coming to the while loop, the syntax follows like this: while condition followed with the procedural assignments. Okay, so this procedural assignment is nothing but the specifying some variables. Okay, onto that variable some values can be indicated, and then this loop will keep on iterating and executing till the condition is evaluated to be false. So here the while loop till the condition it executes to be false. Okay, when the condition is false or else when it is 0, till this condition, this while loop, the statements, the condition, the statements will be executed. So if the condition is an undefined or impedance value, what is this undefined and impedance value? X or Z. Okay, already we had discussed what is this X and Z, high impedance value, and X is nothing but, so X is nothing but the don't care condition, isn't it? So if the condition is undefined or else a impedance value, high impedance value, then it is taken as false statement. So until this the result goes to 0 or false, the statements will be executed, the while statement will be executed. So hence the loop and the statement under will not be executed. So whatever the loop that you find under this while statement, though the output is 0, though the output is 1 if you find, but then it will not stop. Then it will goes on executing the statement. Here in the example, while enable is greater than 0, begin A less than 1 and B minus 1, I'm ending up with the keyword end. So here if you observe, what I said here is the condition is evaluated to be false, 0. So until and unless the condition is found to be 0 or false, the while loop will be getting executed. The while loop can be execute the statement followed with it. So here while greater than 0. Okay. So here it will execute this statement, a less than or equals to 1 and a is equals to 1 and module. Here enable greater than 0. Okay. So here the most of the times like for the multiplexers, for the encoders and decoders, the best way of considering the looping statement is while loop. We'll be considering. And this is one more example. Here increment count from 0 to 127. Exit at 128. So here we will see by using the while loop how the execution or else the increments goes on from 0 to 127. At 128, what it's saying, the while loop will exit. So here we'll see. Now the display will display the count variable. So integer count. Now I'm counting integer count, initial, and then I have to begin, and then I have to count from where? From 0 to 127, isn't it? From 0 to 127. So count 0 while. So here from where till 127 I have to count, right? At 128 I need to exit. So I must count from while count less than 128. Obviously 127 is less than 128, isn't it? So while count less than 128 and it execute loop till count 127. Obviously I have to count from 0 to 127. So here it execute the while statement, the condition will execute the loop till 127. Why? Because it will exit at 128 and then it exits at 128. That's what we are saying. And then begin. Now I wanted to see. Okay, just in order to see or observe, display count percentile d count and count plus 1. So I'm counting, right? So I must count from 0 to 1 plus 1 plus 1 plus 1. So 0, 1, 2, 3, so on. I must count to 127. Okay. So count is equals to count plus 1 and n this is end. So this is how we can write a while loop syntax for a example. In the exam point of view, if you come across any question regarding this looping statements, particularly asking about the while loop, then you can write down this particular example. The counting, simply counting from 0 to 127. Coming to the for loop. Okay, so for loop, for initial assignment followed with a condition and step assignment. So here in this for loop, we will see two assignments. Assignment followed with the statement and followed with the assignment. This is nothing but the for loop. Why? Because for assignment I is equals to 0 or 10 and the statement I less than 1 or 10, then I plus plus. Okay, this is what we will see in the for loop. So initial assignment, condition, step assignment. Then the for loop, it repeats the execution of the procedural statement for a certain number of times till the condition is true. So this for loop, it executes for certain number of times. It doesn't mean, it means that it cannot stop the execution for one time or two times. But for several number of times, the for loop the execution of the for loops takes place for several number of times until the result gets true. Okay, until the result gets true, the for loop can be executed for several number of times. So here, the initial statements, what it specifies the initial value of loop or the index variable. Okay, as I said you in the example, my index variable, that is for a is equals to 10. This is my initial statement. Okay, so the initial statement, it specifies the initial value of the loop or the index variable. So this is my index variable and this is the initial value of the loop. And then the condition specifies the condition for which loop will keep executing. So for particular conditions, whatever the conditions that we are coming across, or else whatever the conditions that we have to follow, we have for that condition, the condition specifies the condition for the while for the loop will be keep on executing. Okay, and the step assignment is directs a variable to be incremented or decremented. That is what I have given here example. That is incremented or decremented, right? That is a step assignment. So for initial statement, for I is equals to 0, and here is a condition, I must be less than 10, and here is a step, I plus plus. Okay, so here, as I said you, in the loop statement, we can modify the values. Okay, whatever the values that we had initialized initially, whatever the values that we have given to the variable, we have a chance to modify it. Okay, so that is one of the advantages that we can find in the for loop. So here, this is my basic, basic way of writing the for loop. And also, as per the rules we have for the for loop, I can also write I is equals to 20. I can modify the value I is equals to 20, I less than or equals to 20, and then I minus minus. So here the step assignment states that it doesn't mean that it only increments, but as well it decrements. Okay, so here I'm incrementing and here I'm decrementing. So this is how I can write the for loop condition. And then here this is an example. So here in this particular example, I'm initializing my variable as I. So I is a variable. I'm initializing with I, integer I. For I is equals to 0, I less than n minus 1 and I plus plus. Okay, and then bus I. So here what am I doing? I'm incrementing, right? I plus plus, this is what am I doing? So here bus I. So for each and every point, I'm just incrementing with the initial value that I've considered. So here I'm considered 0. So next step 0 plus 1. And the next plus 1 plus 1. Okay, then next plus 2 plus 1. Like that I have to increment. Why? Because my step assignment, this is my step assignment. This is my step assignment. This is a condition. And this is the initial assignment. Okay, so as per this I have written, and as it is incremental, so I have to increment bus I plus 1. If for suppose I need to decrement, so what should I write here? Bus I followed with bus I minus 1. So this is how I can write for the decrement. And this is all about the for loop. Now we will see with an example. So this is an example of integer count. So here, initial for count I is equals to 0. That is count I is equals to 0. And count I less than 128 of bits I need to count. And then I is equals to I plus plus. Okay. So here I am doing incremental. So now I want to display. How can I display? Count, percentile D, count, obvious. Then for loops can also be used to initialize an array or memory as shown. So here for loop they can also use to initialize the memory and as well as the array. How is? Now initializing the array elements. So here define max states 32. Okay, now integer states O max minus 1. So here what does it mean? The comments that we have here is integer array states with elements. So these are the elements, right? States with the elements. So here how many states? 32 states, for example. So here 0 to 31, that means totally 32 states. And integer I initializing, and then I'm beginning for I is equals to 0. I less than how many? 32 states, right? 32. I less than 32, and then I is equals to I plus 2. So here what? All the even locations with 0. So here 32, I'm having the 32 states. Max states are 32, right? So for all the even locations, I'm representing it with 0. And for the odd locations, I have to represent it with 1. So that's the reason I mentioned here. For state I is equals to 0, this is for all even. And for state I is equals to 1, this is for all odd conditions. Okay, so here I'm just representing by considering the count. So I must count from 0 to 128. So less than 128. This is just a representation of a while loop. For example, if you are considering, or else if you want to write a program for loop using this array, or else using the memory or else array, in this particular array example, I've considered the max states are 32. As my max states are 32, what am I doing? For I is equals to 0, I less than 32, and I'm incrementing with I plus 2. Okay, so here I'm just for the even locations. For all the even locations, I'm representing with 0, and for all the odd locations, I'm representing it with 1. Okay, finally, I'm just ending up the loop. This is about the for loop. And coming to the repeat loop. So here, what does this word repeat means? So this repeat loop repeats the execution of the procedural assignment a specified number of times. So a specified number of times, how many times if you want to repeat the loop in order to get a proper, or else in order to observe a proper output, those many times you can repeat the sentence. You can execute the statement. So that is nothing but a repeat loop. So here the syntax for the repeat loop follows like this: repeat, loop count, procedural statements. So repeat, it's very simple to remember. Repeat, loop count, and the followed with the statements, that is procedural statement. So in the example below, the loop count is denoted by count. So here this is the loop count. And the procedural assignment. So this is nothing but the procedural assignment. So here, until I should get sum plus 10, so till this extent I can repeat, okay, or else I can repeatedly execute the statements. So this is very easy and simple to remember, that until I get, okay, I get the output, whatever the desired output I have to get, I can I can specify the number of times the execution of the statements can be done number of times. Okay, so that's nothing but the repeat, count, sum, that is equals to sum plus 10. So until this thing I can execute the statements repeatedly. So here repeat followed with the loop count and sum, which is equals to sum plus 1. So we'll see the example. Here in the repeat count, increment and display count from 0 to 127. So here the particular example saying that to display the count, increment and display the count. So we have to ponder on two things. We have to increment and as well we need to display. So it goes like this: integer count initial followed with the begin count. I have to count from 0 to 127, isn't it? So count 0 and then repeat how many times? Till 127 I have to repeat it, right? So 128 times I can repeat until I get the output or until I count from 0 to 127. Okay, that means what? In logically or else in generally, if you remember this repeat loop, for example, if you want to count from 1 to 100, sometimes what happens while you are counting, because of some disturbances or the interruptions from the opposite side, sometimes we'll miss the count, isn't it? So what we will do again we'll start counting right from the starting. Okay, the same follows here. So count 0 and then repeat 128, begin, and now I want to display, right? So display count percentile and the count, and now I'm done with the display. Now my task is to increment. So count, I have to increment. So in order to count from 0 to 127, what I need to do? I need to count plus 1 and so on, right? So count is equals to count plus 1 and then finally close the loop. So this is about the repeat statement. You just, if you want to repeat or else if you want to count something, when you have missed in between, what you need to do? Again, you have to count right from the starting. So here until you observe the output, you can count the several number of times. So this is what the count says, repeat loop says. And coming to the forever loop. So here this forever loop is forever followed with the procedural statement, and this loop continuously executes the statement. So the word says that forever. So forever is continuous, right? It doesn't stop somewhere or anywhere. So this loop, it continuously executes the procedural statement, and thus, to get out of such kind of loop, a disable statement may be used with the processor. So sometimes what happens in between, you can use, there is a chance of disable statement. Okay, so a kind of statement where there is no way of use. So we can also make use of such statements in between while executing the statement. So here forever loop is nothing but it executes the statements continuously. And in between while you are executing, we can replace or else we can place some disable statement as well. We can use in the with respect to the procedural statement. So here, example, initial, forever, 10, clock, negation of clock. Okay, you know what is this 10 clock represent? 10 nanoseconds of delay. And the output that I can get is a negation of the clock, whatever I'm getting. Okay, so if it is 10 clock, I may get it at 20 clock. So like that. So forever, we can continuously, it executes. But with a delay of 10 here in the example we had seen. And now we'll see the clock generation example here. So in this clock generation, use forever loop instead of always block. So here, register clock, as it is a clock generation, register clock, initial, and begin with my clock as 1 bit. Okay, 1 binary bit. So forever 10 nanoseconds of delay clock, negation of clock, that is clock with period of 20 units. Obviously the 10 negation of 10 means the 10 more minutes I am adding up. So for this 10, I'm adding up 10 more nanoseconds. So totally a clock with a period of 20 nano units or as 20 nanoseconds, I can progress, or else I can make the inputs or the outputs to propagate. Okay, so here forever loop is it says that forever loop instead of always block. So here in the behavioral modeling, in order to write a syntax, always is a keyword, always at the rate. So this is a keyword where we need to initialize in the syntax, right? So here in this behavioral modeling, in place of using this always at the rate, we can use this repeat. Okay, we can use the forever loop. Sorry, so we can use the forever loop. Just to replace the always at the rate, as the always at the rate is the basic keyword that we can use under behavioral modeling. So this is about the forever loop. So today's class we have discussed what are the looping statements and what are the different types of looping statements, and with the examples, right? So coming up again, so looping statements are nothing but we have 4 types of looping statement: while, for loop, forever, and repeat. So each and every looping statements had as their own specification. So when it comes to the repeat is nothing but in somewhere in the between, if you have missed something, so you have a chance to repeat it again for several times. Okay, so specified until the specified number of times the loop can be, or else the statements can be executed. Whereas the forever statement states that it continuously executes the statements, whatever the statements are need to be executed, it continuously, without any break, the statements will be executed continuously. Okay, one after the other, the statements can be executed. Coming to the for loop. For the for loop, we had discussed about the 3 steps. The for loop, in order to execute the for loop, we had 3 steps to be, or is 3 rules to be followed. Okay, what are the 3 rules? The 3 rules are nothing but for it has a variable. Some variables can be, values will be dumped onto the variables, and the values can be modified. And here the values can be modified, and as well the values can be increment or decrement. Okay, based on the statements, we are calling the initial statement followed with the condition and followed with the expression statement. Okay, so here this initial statement is nothing but the dumping of values onto a variable. First, you initialize some variable I is equals to 0, and then I'm dumping my value 0 onto the variable I, and then goes with the condition. My condition is I less than n, or else I less than 10. Okay, this is a condition followed with the increment or decrement, that is I plus plus or I minus minus. So here in the for loop, we observe that the values can be modified, and the values can be increment or decrement. And also we have discussed, say here, this is for loop, right? Yeah. So for loop statement repeat the execution of the procedural statement for certain number of times till the condition is true. So till the condition gets true, the for loops can be repeated the number of times. There is no restrictions that for so and so times only the for loops can be executed. But here, until and unless you are getting the output as 1, that means the condition is becoming true. So till that end we can execute the statement. And here goes like this: initial assignment, condition and step assignment followed with the things. And if here I'm considering the plus plus as increment, when you consider the decrement purpose, you can consider this bus I minus 1. Okay, and this is an example that we had considered. Also, when it comes to the while, so here the while states that just to keep on executing until the condition is available to false. So until the condition, the statements which are executed evaluated to be false, that is to get 0 or false. So till that extent we can iterate, or else, and also we can execute the statement. So here sometimes what happens, if the condition is some x or 0, undefined conditions or the high impedance of conditions, then it is taken as false statement. So whenever you're coming across the high impedance values or else the statements, they don't get conditions or the high impedance statements, then the condition is to be considered as false. Okay, and For the false statements, or else the loops and the statements under will not be executed. So under the loops or else the false statements, when we are saying the loops should be false, when you are coming across X and Z, that is high impedance state as well as the don't care conditions. When you are coming across X and Z, obviously the statement will becomes false, and when the statement is becoming false, we see that there is no execution. That means what, the statements will not be executed. Okay, so these are the examples that we have considered, and what else we have discussed? That's it. So this is about a general way of writing a syntax for all the different looping statements: forever, repeat, while, and for. Each and everywhere you can see some statements followed with the condition and as well, and also with the keyword forever, statement followed with the statement and with the conditions, and that conditions will be writing only in the begin and end. The conditional statements will be written only within the begin and end blocks. Only within the begin and end blocks, the conditional statements will be written. So if you observe here, all the 4 looping statements, only in the begin and end, you will see the conditional statements. Okay, followed with respect to the looping, with respect to the keywords while, forever, repeat, and as well for. Only among these 4, only the for loop has a special special thing that it has to, in order to execute the statements in the for loop, we have to follow the 3 steps. Okay, those 3 steps are already we have discussed. So this is all about the today's class, looping statements. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.